All right, everyone, what's up? Mr. D'Souza here. We're going to go over the exam review questions that we posted. A lot of you have been asking me about that. So here that is. This is what I'm going to suggest. These questions are extraordinarily similar to what you're going to see on your test. Use this video. Use the videos that we've already have given you to help you answer the questions on the test. You have so many resources, your notes, the videos, the homework, everything that we've been doing, okay? If you have any questions in regards to how to access the exam, or you're confused of where to go or anything, reach out to your teacher, myself, Ms. James, Ms. Fu. With that being said, let's go through these questions. The first question says, which of the following describes a central angle? Now, central angles look like the following. You have a circle, and it's an angle whose vertex comes from the center of the circle extending to the circumference of the circle. Okay, so it's not an angle in the center, because the angle in the center of what, right? So it can't be this one. An angle whose vertex is in the center of the circle and whose rays extend to the circumference, that sounds exactly what I just said. An angle whose vertex is on the circle, that's an inscribed angle. Any angle, that's just silly. Answer 2. The definition: central angle, center of the angle the vertex of the angle is the center of the circle, and the rays of the angle extend to the circumference of the circle. Moving on. So Ms. James says that arc BC is this arc, is half the measure of angle BAC. So let's check that out. BAC is that angle. The first thing you want to ask yourself is, well, what kind of angle is that? And then we can go from there. So that is an inscribed angle, because inscribed angles, the vertex of an inscribed angle is on the circumference of the circle. Okay, so angle BAC is an inscribed angle. This is literally just asking you the definition. An inscribed angle is half the measure of the intercepted arc. So angle BAC, right, is half the measure of the intercepted arc. Now let's go back to the question. Actually, before we go back to the question, this question is asked a lot on the Regents because people get confused. What's half, the arc or the angle? Inscribed angles is half the measure of the arc. Okay, the angle is smaller than the measure of the arc. Ms. James says that the arc BC is half the measure of BAC. Is that true? Is the arc smaller than the inscribed angle? No, we just said it's the opposite way, right? That the angle is half of the arc. Okay, so this is wrong. Disagree. I disagree because the definition of an inscribed angle, the angle is half the arc. The arc is not half the angle. Okay, please go back to the video about inscribed angles, and that's really just the definition. All right, third question. Let me move my picture so I can actually see. All right, so given the following diagram, line segment DF is a diameter. That's going to be super important. And line segment CF is a chord. Also important. If the measure of angle DFC is 75, mark up your diagram. Boop. Oops, let's make that obvious. Then the measure of arc CF is what? So we want to find this arc. Like we always say, follow your nose. What's the only thing they give us right now? They give us an angle, and they explain what these lines are. So that being said, the only thing we can do is play around with this angle. So if the angle is 75, remember that's an inscribed angle. The vertex of that angle is on the circle. So the angle is half the measure of the arc. So that means the arc is double the angle. So I'm going to use my calculator. What's double of 75? So 75 times 2 is 150 degrees. But they tell us that DF is a diameter. And remember, diameters are cut a circle in half. which is 180 degrees. So that means the green arc plus the yellow arc, so green plus yellow is 180 degrees. Well, we know the green arc. The green arc is 150 degrees. The yellow arc, we don't know. That's what we're looking for. And that should equal 180 degrees. So we can solve by subtracting 150 on both sides. And you get the following, that arc, or rather the measure of arc CF is 30 degrees. Okay, remember diameters are half the circle. If the full circle is 360 degrees, half the circle is 180. All right, in the diagram of the circle below, a line segment AD and BC are parallel. Okay, that's important. I'm going to highlight that. Arc AB is x plus 10 degrees, and arc CD is 6x minus 5 degrees. Again, they're just writing the arcs in a different way. Instead of saying, oh, it's 70 degrees, it's giving you an expression. So that being said, this talks about parallel chords. Line segment AD and line segment BC are chords. When chords are parallel, the arcs that they intersect, so that means this arc and this arc, right? It's like the piece that they cut off, they're congruent. And if you forget that, if you're like, I forgot what happens with parallel chords, just look at the picture. The picture kind of actually just shows that they look the same. Anywho, so that means we know the following, that x plus 10 is equal to 6x minus 5. Okay, we want to solve for x. So we want to get our x to one side and then move everything to the other side. So I'm going to move my x to the other side. So I'm going to subtract 1x, right? Because coefficient is 1. And I'm left with 10 equals 6x minus 1x is 5x. If I want to get x by itself, I got to add 5 to both sides. I'm going to rewrite it over here. So 5 plus 10 is 15. And then we're just left with 5x. What's the inverse of 5 times x? Well, divide by 5, right? Inverse operations. X equals 3. Are we done? Absolutely not, because we're looking for the measure of CD, and the measure of arc CD is 6x minus 5. Well, I know that x is 3, so 6 times 3 minus 5. I'm doing on my calculator, even though the answer is there. 6 times 3 is 18. 18 minus 5 is 13. So the measure of arc CD is 13 degrees. I don't know if you noticed this yet, and I really hope you are noticing this, but when it comes to circles, I mean, this is actually a fact that belongs to anything in math, but specifically this unit, I think it's a little bit more obvious. It's you're given a question, and you're using facts to figure out how to relate certain parts of the circle, and you're creating an equation to help you find your answer. Let's go back actually for a second. Right, for this question, we related parts of a circle, inscribed angle, a diameter is 180 degrees, and we used those facts to create an equation to help us solve whatever the problem is. That's really all math is. All math is using facts or things that are true to come up with an answer to something. So let's try it with this. Using the diagram below, ABCD is a cyclic quadrilateral. Remember, cyclic quadrilaterals, we know two things. A cyclic quadrilateral means that it's a quadrilateral inscribed in a circle. Inscribed, similar to inscribed angle, means that all the vertices touch the circle, the outer part of the circle. And then the other thing we know about cyclic quadrilaterals is that opposite angles are supplementary, meaning they add to 180 degrees. So, cyclic quadrilateral, there are two facts here. We want to solve for x, so somehow I need to relate these two expressions. Well, they're opposite angles. The fact that I know is that opposite angles in cyclic quadrilaterals are supplementary. So 3x minus 5 plus 110 is 180 degrees. Okay. I'm going to simplify 3x. Now, negative 5 plus 110 is 105. Solve for x. Subtract 105 on both sides. Whoop. 3x equals, let's do 180 minus 105. Because I want to use my calculator to make sure I have the correct answer. So that's 75. Whoops. We're going to divide by 3 on both sides. 75 divided by 3 is 25. Now, is it degrees? Well, let's see. It's asking us what is the value of x. It's not asking about an angle. So there actually are no units. So it's just x equals 25. If it asked us what's the measure of angle A, then your answer would be in degrees. But because they didn't ask that, we're just going to leave it as 25. Okay, 2 more. All right, we actually did something similar to this on one of the practice problems. In the diagram below of circle O, chord CD is parallel to the diameter AOB. The measure of arc CD, so measure of arc CD is 130 degrees. What is the measure of arc CAB? So before we get to arc CAB, let's see what we can play around with. It's telling us that the chord is parallel to the diameter. Well, a diameter is a special kind of chord. Remember, diameters are chords that go through the center of the circle. So we know that CD is parallel to AB, which means we also know that DB and CA are congruent because parallel chords intersect congruent arcs. Okay? So that means that CA is congruent to DB. Well, check this out. Isn't the whole thing over here, isn't the red equal to 180 degrees? Because the diameter cuts a circle in half. So arc ACDB, that whole red arc, is 180 degrees. And the arc that I highlighted in black, CD, is 130. So if I take 130 away from 180, you'll get arc CA and arc DB. It's kind of like me doing this. If I got rid of this arc, I subtracted 130 from 180, you're left with that. So using my calculator, 180 minus 130 is 50. So that means CA, let me actually not use red. Let's do a fun color. Let's do purple. That means arc CA plus arc DB, right? What I'm left with is, what did I say, 50? 50. It's 50 degrees. But wait, isn't CA the same thing as DB? So I can just divide that in half. That means arc CA is 25, and arc DB is also 25 degrees. Okay, but here's the thing. Let's go back to the question. I want CAB. So C to A to B. That means I need arc CA plus AB. But AB is a diameter. So let's highlight this for you. This arc is 180 degrees. This yellow arc, right, the one that we just found, that's CA, is 25 degrees. So if I add those two together, that's 205 degrees. So the measure of arc CAB, right, that's a major arc, so we have to use 3 letters, is 205 degrees. Whoops, lagging a little bit. Equals 205 degrees. Last question. We actually literally have done this question in the mini lesson. If I'm not mistaken, or the practice problem, it's literally the same question. In the diagram below of circle O with diameter BC and radius OA, chord DC is parallel to chord BA. Cool. So this is parallel to this. If the measure of BC of angle BCD is 30, determine AOB. Okay. Just like what I said in the video. If you don't know, right, so let me fill everything in, 30. If you don't know, just use what's given. The only number that they give us is 30. So we got to do something with 30. 30 represents this angle, or what happens to be an inscribed angle. The angle is half the arc. So the opposite is the arc is double the angle. So that means DB is 60 degrees. But hold on. Chord DC and BA are parallel. Parallel chords intersect congruent arcs. That means this arc is also 60 degrees. Now remember, we want this angle. I want to get close to that angle. Well, check this out. This angle happens to be a central angle. Central angles are equal to the arc they intersect. So, angle COA is this angle, is also 60 degrees. Now I'm going to highlight something for you. Okay, check this out. Boom. Oops, a little messy. See what I highlighted? I'm going to bring it over here. It's a straight line, right? It's a diameter. Super important. 10. This angle happens to be 60 degrees. And we're looking for this angle. Well, we know straight angles, their angles sum to, a straight angle is an angle, it's a straight line. We know straight lines measure 180 degrees. Two angles that are adjacent, that form a straight line, are called linear pairs, remember? So that means x plus 60 is 180. So x plus 60, I'm lagging, is 180. So getting x by itself, subtract 60 on both sides. Boom, x equals 120. So our final answer is the measure of angle AOB is 120 degrees. Okay, I hope this was helpful. Please use this video for a reference, for your reference when you are trying to practice for the test. Even when you're taking the test, if you have to look back on something, look at your notes, look at the past videos, look at this video. I'm very sure that it will be very helpful, okay? Have a great rest of your day. Good luck. You're going to do amazing. Have a great day.